Welcome students. Today we will start second chapter, Units and Measurements. Today we will learn about topic 2.1, introduction part, then topic 2.2, that is about the international system of units, and then about this table 2.1. Now students, many phenomena occur in our surrounding. We observe such phenomena. Some are natural and some are man-made. And to describe such phenomena, we need to measure the physical quantity related to it. For example, if we consider an object falling towards the earth, that is on the ground, here there is a need to measure the mass of an object, the velocity of an object with which it is falling on the earth. During the fall, the body has an acceleration. During the fall, we can say that it must be falling due to some force acting on this object. Here we know that that force is a gravitational force. Now, if the object is falling from some height to the ground, then that height is to be measured. Also, the time taken to cover this much distance during its fall, and also many other physical quantities are related to it. So we can say that the length, mass, time, force, acceleration, etc., these are the physical quantities which are required to be measured. Now, why it is required to be measured? Because we can compare if there is a proper measurement. Why comparison is needed? It is because if we consider a stick, then to answer about its length, we need to compare this stick with the standard measurement in case of length. I can say that this stick is shorter or longer if there is a comparison. Suppose I am comparing this stick A with a standard stick or the standard measured length of the stick B. In comparison of A with B, I can say that this stick is shorter than this stick, means A is shorter than B. But if the standard measurement B is this, then in that case I can say that A is longer than B. So for this stick A, it is shorter or longer. To tell this answer, we need to compare it with some standard measurement, and that's why comparison is important. And so here, this length, mass, time, etc., these are physical quantities which are required to be measured, and these are used in our day-to-day life. We used to observe the time in our day-to-day life. We used to measure the mass when we go to the market to buy some things. We used to measure the length also. So we can say that for any physical quantity, a unit is related to it. Length is a physical quantity, and we used to measure the length in terms of centimeter, meter, kilometer, etc. Here we say that the centimeter is a smaller unit, then meter is larger unit than the centimeter, kilometer is still larger than the meter. Similarly, mass is also a physical quantity. We measure the mass in terms of gram, kilogram, quintal, and so on. Time is also a physical quantity. We measure time in seconds, in minutes, in hours, and so on. Now, about different systems of units. This different system of unit came into existence at different places and different times. Among these different unit systems, the first is FPS. This FPS system was developed by Britishers, and so sometimes it is also called a British system of units. In this unit system, the length was measured in terms of foot. Mass is measured in terms of pound, and time is measured in terms of second. Then after the second unit system came into existence. The second unit system is Cgs system. In this system, the length is measured in terms of centimeter. The mass is measured in terms of gram, and the time is measured in terms of second. And so it is called Cgs system. Then after that, the MKS system came into existence, in which the length is measured in terms of meter, mass is measured in terms of kilogram, and time in terms of second. And so this system is called MKS system of units. So in earlier times, only three physical quantities were important: length, mass and time. But after the invention of electric current, even electric current is needed to be measured, and so a proper unit related to an electric current is needed, and that unit is ampere. And so this MKS system of unit was upgraded, and the new system is known as MKSA system. So these three units are as it is for length, mass and time. But for electric current, the ampere is used, and the initial letter of ampere is A, and so here there is an A. So at different times and at different places, these unit systems came into existence. Here in last unit system, you can say that there are four physical quantities and the units related to it. But after that, new physical quantities came into existence, and finally system international is applied for the measurement of such physical quantities, in which there are seven physical quantities and their units. Now this system international means it is the internationally accepted system of units. Means in all the countries this system is applicable. This SI system was accepted all over the world in 1971 by the 14th General Conference of Weights and Measurement, and this conference was located at Paris in France. Now there are many physical quantities. Among these physical quantities, seven are fundamental or base quantities, two are supplementary quantities, and the derived quantities are many. Internationally accepted seven fundamental or base quantities are given in this table. Table 2.1 of your textbook. In this system of units, length is a physical quantity. Its unit is meter, which can be written in full form as metre, and if we want to use only symbol for meter, then it is small m. Similarly, second physical quantity or base quantity is mass. It is measured in terms of kilogram. This is the full form of the unit, and this is the symbol. Means we can write kilogram in full, or if we don't want to write this full form, then we can simply use kg. Then time is a physical quantity. It is measured in terms of second. So this is the full form of unit of time, and this is the symbol for this unit. Next is electric current. It is measured in terms of ampere. If we don't want to write this ampere in full form, then we have to use the letter capital A for its unit symbol. Similarly, the next physical quantity is thermodynamic temperature. Students, we know that even temperature is required to be measured. When we have a fever, we used to measure the temperature with the help of thermometer. Even in many industries, during chemical reaction, the temperature is required to be maintained, and for that it is to be measured. So the temperature is a physical quantity and its unit is Kelvin. In full form, you can write Kelvin like this, and if you want to use the symbol, then simply capital K. Now this ampere, this Kelvin, these are the units, but on the name of the scientist. Here this ampere is nothing but the name of scientist. Even this Kelvin is a name of scientist. So this scientist, they have contributed for this physical quantity or related inventions. Next is about amount of substance. Any substance is made up of atoms or molecules. So how much molecule or the atoms are there in that substance is required to be calculated or measured. So this amount of substance is a physical quantity and it is measured in terms of mole. You will find this type of unit mainly in chemistry. Even in physics also you will find this type of units. Symbol of this unit is MOL. Students, one question may arise that why here the symbol is not taken simply M for this mole. It is because this symbol is used somewhere else also. Somewhere else means we know that for length we used already this symbol for meter, and so that cannot be repeated, and so the symbol or the short form of the unit for amount of substance is taken as MOL. The last base quantity is luminous intensity. Intensity is generally related to light or even other radiations which are not visible. We know that light is visible, but there are many radiations like X-rays, gamma rays, and other electromagnetic radiations which we cannot see. So intensity is related to the radiations. Its unit is candela. In short form, it is written as Cd. In our house also, we use different bulbs with different intensity of light. The bulb with less watt means it is unit of power. So bulb with less power has less intensity, and the bulb with high power has high intensity. So even this intensity can be measured, and if it is measured, then it must have its proper unit. So this is all about the 7 fundamental units and the physical quantities. Next is about supplementary units. Now there are two supplementary units. One is plane angle and the other is solid angle. The unit related to this physical quantity is radian. In full form we can write radian like this, and in short form we can write it as simply RAD. For solid angle, the unit is stradian. This is the full form, and the short form of stradian is SR. Now, what is this plane angle and solid angle? To understand this, consider this figure. In this figure, you can see there is a arc. We know that any arc is a part of a circle. You can see this is a circle, and if I take this much part of a circle, then we can see that it is an arc of a circle. So any curved region has a arc, and if this is the arc having length L, and if we join its 2 points with the center O, then it makes some angle at point O. This angle is theta, which is called a plane angle. Why word plane is given here? Because circle is a plane figure. We can draw a circle on a plane page. So it is a plane figure, and this is angle related to this plane figure. And we know that any circle has a radius, and as this arc is a part of any circle only, so this distance is nothing but it is radius. So we can relate this radius r, length of an arc L, and the plane angle related to this is theta. So their relation is theta is equal to L by R. That is, plane angle theta is length of arc upon radius. Now, solid angle. We have seen earlier that a circle is a plane figure, and this arc is related to that plane figure, which is two-dimensional. But if we consider a sphere is a solid object, and so if we cut a sphere, it has its surface, and so if we join all these corners of this surface, they will meet at a center. center of the spherical solid. And so at this point O, something like angle is made, and that angle is called solid angle. You can take an example of a watermelon. If you cut a watermelon, then you will find such type of shape. Here, this shaded part can be considered as a green surface of a watermelon. So, even here the angle is made, and symbolically the formula for such solid angle is given by sigma is equal to area upon radius square, because for a sphere also there is a radius. You can see here there is a radius of this spherical surface area. Like for plane angle there is a length, but for a solid angle there is area. So this is about the two supplementary physical quantities. And the last is derived physical quantities. And these derived quantities are many. I'll give you one or two example for it, and then we will study about the derived quantities later on. If I say velocity or speed, speed s is equal to distance upon time. So here this physical quantity speed is related with two different fundamental quantities. We know that distance or a length is a fundamental physical quantity. Even time is a fundamental quantity. So this physical quantity speed is combined by two fundamental quantities, and so it is called derived quantities. And if I say what is the unit of this derived quantity speed, its unit can be given as meter per second. Why? Because this distance is measured in terms of meter and time is measured in terms of second. So speed is a derived physical quantity. It is made up of two fundamental quantities, length and time. A next example is, suppose volume of a cube or a cuboid. Any cube or a cuboid has its length, its breadth and its height. And we know the formula of volume, V is equal to L B H, for any cube or any cuboid. So here this physical quantity, that is volume, is the combination of these three fundamental quantities, length, breadth and height. They are nothing but the first fundamental quantity L, and its unit is meter. So here length is in meter, even breadth can be measured in terms of length only, even height is measured in terms of similar way. So all these three has unit meter, and so meter into meter into meter, 3 times meter, so we get meter cube. So unit of volume is meter cube. So here also there is a combination of three fundamental quantities of similar kind, and so this volume is a derived physical quantity. So we will have such type of many derived physical quantities.